All right. So we start off with doing matrix operation. We're dealing with some properties, and the first thing is how do we add matrices together? Again, on the test, expect to see an x and a y somewhere in the problems. I do that just so you don't use the calculator completely, and that you're forced to know how to do it. How do you find a plus b? You simply add elements. So the first one would be x plus 7, 3 plus negative 2, negative 2 plus 1, and 4 plus y. We write the x plus 7 and the 4 plus y as just x plus y and 4 plus x plus 7 and 4 plus y.
Wouldn't that one be negative 1? Because you're adding negative 2 plus 1.
You get an extra 5 points.
Okay, thank you.
Off of Stefan's grade. You just got to convince him it's a good idea.
Can you afford it, Stefan? Yeah, you can.
Stefan's like the Warren Buffett of pre-calculus. He's got points to spare. All right. A minus B would be x minus 7, 3 minus negative 2. 3 minus negative 2 would be 3 plus 2, which is 5. Negative 2 minus 1. Negative 2 minus 1 is negative 3. And 4 minus y. Those two should be pretty straightforward. Okay. Thanks. I could do other things like solve for x if a plus b is equal to some matrix, and then you'd have to be able to figure out what x and y are. All right. Did everybody hear that? That's important. Okay. All right. Now, how do we do times? Times is a real mother. So for the times, remember that we're doing row by column. It's the first row, first column, so that answer is going to go right here. Okay? It's the first row by the first column, so that answer goes in the first row in the first column. So this is x times 7 is 7x. 3 times 1 is 3. And so this piece is 7x plus 3. Now we'll do row by column again. So it's row by column. X times negative 2 is negative 2x. 3 times y is 3y. Do we agree? Now we're doing row by column. Negative 2 times 7. Negative 2 times 7. And 4 times 1. That is negative 10. And then row by column. It looks like I've exhausted all my color possibilities. We'll go here. Row by column. Negative 2 times 2 is positive 4. Plus 4 times y is 4y. All right. Now, if you have a 3 by 3, how do you do that? And by the way, they don't have to be square. And we'll do an example here in a little bit where they're not square. All right. Just the number of columns have to match the number of rows. The number of columns here have to match the number of rows here. As long as that's the case, it'll work. Okay. How do you do 3 by 3 though? This one is a royal pain in the rump. Although all the zeros will make it somewhat nice. It's row by column, row by column, row by column. And that will be the first line. Then you'll do the next line, row by column, so forth and so on. So your final answer is 1 times 2 is 2. 2 times negative 1 is negative 2. 0 times, no, shoot, bang. For those of you watching at home, beep, I dumped that. All right, let's try it again. 1 times 2 is 2. 2 times 3 is 6. 0 times 0 is 0. So that first column has an 8 here. Do we agree? 1 times 2 is 2. 2 times 3 is 6. And I'm pointing like you can see it, but sorry, you just got to pretend. 0 times 0 is 0. Now, next column over. 1 times 0 is 0. 2 times negative 1 is negative 2. 0 times 2 is 0. So this next piece is negative 2. Now doing row by the third column. 1 times 1 is 1. 2 times 0 is 0. 0 times 1 is 0. So this is 8, negative 2, 1. Let me pause there for station identification. We did the first row by each of these 3 columns. This is the first one, this is the second, this is the third. So it's 1 times 2, 2 times 3, 0 times 0. 1 times 0, 2 times negative 1, 0 times 2. 0 times 1, or no, excuse me, 1 times 1, 2 times 0, and 0 times 1. Does that make sense? Now, that's the first row. But you still got, now you're a third of the way there. Now you got to do the second row. So second row times the first column, second row times the second column, second row times the third column. Is that okay? So we got 0 times 2 is 0. 3 times 3 is 9. Negative 1 times 0 is 0. Do we agree? So that makes this piece here a 9. 0 times 0 is 0. 3 times negative 1 is 3. Negative 1 times 2 is negative 2. And I didn't write any of that down. Genius. Negative 3 and negative 2. So this number has to be a negative 5. Ferris, we doing okay? I just wanted to say your name on the internet. All right. Now, 0 times 1. 0 times 1, 0. 3 times 0 is 0. Negative 1 times 1 is negative 1. So we got 0, 0, and negative 1. Makes this number negative 1. And lastly, it's the last row by the 3 columns, 1, 2, and 3. 0 times 2 is 0. 1 times 3 is 3. Negative 1 times 0 is 0. That makes this piece a 3. All right. 0 times 0. 0 times 0 is 0. 1 times negative 1 is negative 1. Negative 1 times 2 is negative 2. Makes this piece negative 3. Lastly, 0 times 1 is 0. 1 times 0 is 0. Negative 1 times, is that a negative 1 or a positive 1? I don't even remember anymore. So negative 1 times positive 1 is negative 1. 0 and 0, right? So that makes this number negative 1. Any questions on how to multiply? It just takes forever. It's not really super hard, but it takes forever. The more you do, the better you get. Now, just as a quick aside, and then I'm going to stop the video. If you know how to use the calculator, you go to second matrix. You're going to edit A and B. Now, some of you are going, but they're C and D. Well, it doesn't matter. It's a 3 by 3. And then you type them in. 1, 2, 0, 0, 3, -1, 0, 1, -1. So now you've typed in the first one. Second matrix, edit, go to the second one. It's a 3 by 3. And we're going to type in 2, 0, 2, 0, 1, 3, -1, 0, 0, 2, 1. Do we agree? Having typed those in, what do? Second quit. Matrix. We're going to do A times B. And then you just press enter. Okay. 8, -2, 1, 9, -5, -1, 3, -3, -1. Second, hit the matrix key. It's X inverse. All right. Now, what I'd like for you to observe is this. If I do B times A, I get two totally different answers. There is no commutative property in multiplication as it relates to matrices. There is one if you do addition, right? Oh, you son of a bitch. You son of a gun. Dump that too. If there is one if you do addition, right? A plus B and B plus A will be the same. So there is a commutative property as it relates to addition as matrices deal with, but there is no commutative property for multiplication, unless one of them is an identity, and then and then it would be commutative. But it's not a commutative property; it's an identity property. Okay. All right. With that being said, I'm gonna stop right there.